Okay. Okay, so now we will actually look at each of these components in deep detail. Okay, so of course each of these components is going to be like tens of hours of lectures in the future, but for now we will spend like maybe 10 minutes on each of them. Okay. Okay, so let's first talk about big data infrastructure. This is not new. Okay, this has been around for 10 years. Okay. So this is what people call as the Hadoop wave. When it came about 10 years back, everybody wanted to get into Hadoop, everybody wanted to learn this, wanted to understand what it is, right, and so on. So what is this, and why does it make sense as part of the course, right? As we saw in one of the previous slides, this large amount of data, right? Every minute huge amount of data is getting generated. Okay. For example, Twitter allows you to download tweets for free, right? 1% of all public tweets can be downloaded. Okay. Now, if you just try to download that for a day, you easily need 1 TB of disk to store that. Okay. So that's the kind of data that I'm talking about, and this was actually when I used to do it like 3-4 years back. So surely now 1 TB is not enough. Surely now you probably need 1.5 TB or about 2 TB to store that data, right? And if you want to do some study over a few months, you understand how much of data disk you need. Okay. Now not just the size of the data, but also compute over all this data is a problem. So therefore things cannot be done on a single machine for sure. You have to make use of hundreds and sometimes thousands of machines, right? Do you have those machines? Sure, you can buy those machines and actually make them work. But the problem is, how do you access those machines, and how do you get your job done all across those machines in a seamless way? Okay. One way is to write scripts. Okay, is to write scripts where one of the machines can be like a master machine, and this machine sort of commands all other machines that, hey, you do this, you do that, and then it also commands other machines. You collect it, you collect whatever processing has been done on other machine, and you act as a collector in some senses. Okay, so you can actually write these ad hoc scripts and then take the pain of sort of making sure that all of those machines have done exactly what has to be done, taking the pain of dividing the work among all of those machines, and so on. Okay, if you have 1,000 machines, one will go bad once in a while anyway. Okay, so which also means that when you are writing those scripts, you have to make sure that they are fault tolerant somehow, right? Somehow they understand that, hey, this machine has gone down. You need to really schedule another machine to take care of that, and so on. Okay. What these guys, the Hadoop folks, have done is to basically make all of this automated. Okay. Thanks to the various components in the framework, this has become seamless. It is as if you are writing your program on a single machine. Okay. It is as if the single machine has petabytes of disk, right? And it is as if you have like thousands of processors on this single big machine. Okay. Now HDFS is Hadoop's file system, which makes it seem to a user as if he's referring to the same disk. Okay, so that's the storage, as one can say, in Hadoop. Okay, to think of Hadoop is more like a software. So if it was not already clear, right, you have thousands of machines, but how do you make sure that you run your job all across nicely? You install Hadoop. So Hadoop is a software which you can actually install on all of those machines, right? And in fact, Hadoop also works in a master-slave kind of architecture. So there are master machines which basically command these slave machines so as to do pieces of the job. Now, so as to ingest data into HDFS or this particular file system, you need to bring data from various places, right? So from Twitter and so on, and therefore there are ingestion mechanisms like Flume and Scoop which help you sort of input data into the Hadoop ecosystem. Okay, and then somebody needs to, there needs to be a compute or some sort of processing which takes your job, distributes jobs among these slaves, gets the results back and outputs the results, and so on. All of that is basically done using Yarn, right? So Yarn is basically the distributed processing framework. It makes sure that once you give the job, it distributes the work appropriately among machines and gets it done. Okay, it is also fault tolerant. It makes sure that if a machine has gone down and it was given this piece of the job, some other machine takes up that job and finishes it off. Okay. Then there are many other guys in what is popularly called as the Hadoop Zoo. Okay, or also the Hadoop ecosystem. Okay, so for example, there is HBase, which is basically like a database. So a typical database in Hadoop. Then there is Oozie, which is a workflow system where Jan can actually use it to figure out exactly which job has to be done. You have one big monolithic job. Now after dividing into small parts, which part has to be finished before the other part can start running and so on. So that workflow management is done using Oozie. Okay. Pig and Hive are more like scripting languages. So once you have data, can you run like SQL kind of queries on that data? That's Hive, right, on a very large data set. Right. And then Pig is another scripting language, just like R or Python, where you can actually do very quick scripting on very large amounts of data. Of course, the syntax is very different. Right. Mahout is the machine learning piece. So once you have the data, and this is what connects big data to the machine learning world. Okay. So once you have this big data infrastructure, okay, now this infrastructure adds up as the infrastructure that you need to run your machine learning algorithms on top. Okay. And Mahout is one of those machine learning libraries which is native to Hadoop, which allows you to run these machine learning algorithms seamlessly. Okay. Lastly, you also have R connectors, which can help you get typical descriptive analytics and also run machine learning algorithms within R. Okay, so a lot of algorithms are coded up within R, and you can run them thanks to these R connectors as well. Now, since this entire ecosystem has quite a few components, one needs a good management of all of those components, and that is why you usually have the zookeeper, which is the coordinator guy. Basically, it makes sure that there is good communication between all of these components. They all are up, and they are all doing the jobs that they are supposed to be doing. Right? Finally, there's this thing called Ambari, which basically helps the admin folks to make sure they can do typical admin jobs like maintaining the clusters, the Hadoop clusters. So if you have like thousands of machines, how many machines should be used for this job, right? And it turns out that in the Hadoop world, Hadoop is an example of a map-reduce architecture, as people call it. Okay. Now there are two parts to it: map and reduce. Right. So remember I said if you have a big job, you have to split it into multiple small jobs and then get the results from all of them and combine. So splitting it into multiple small jobs is called mapping in some senses. Okay, very broadly. Okay, and then combining the results of each of them together is very broadly called as reduce. Okay, so therefore all of those map reduce, how many these slaves should act as mappers, how many of them should act as reducers, can be very job specific. Okay, and Ambari is a way where admins can actually tweak around with these parameters that, hey, I want to run this job, but maybe I want to say that, hey, it should have 500 mappers and maybe 200 reducers and so on. Okay, so that's the Hadoop ecosystem. Now how does it sort of help us? Well, this is of severe help. So thanks to Hadoop ecosystem, we can actually deal with the massive data sets that we have. In case you have thousands of machines, you install Hadoop on them, run them locally, and you do machine learning locally. If you do not have thousands of machines, the big data infrastructure, if you still need the big data infrastructure, you go to cloud. Right. Fortunately, there are many cloud providers which give us such platforms at a cost, of course. Right. There's Microsoft's Azure, there's Amazon's AWS, and there's Google's GFS, right, which are the top three, where you can actually do the same work without taking the overheads of being the admin of this entire infrastructure. Right. You don't need to buy thousands of machines. You don't need to do all this stuff yourself. What you can do is to depend on Azure or GFS or Amazon's AWS to do these things for you.